So today we are going to see the basic architecture of Hadoop. So what we will do is basically we will first name the components, basic components of Hadoop. Okay, so that will help us to just like overview the architecture of Hadoop. There are two a very basic part of Hadoop architecture. One is called Hdfs, Hadoop Distributed File System, and second thing is called the MapReduce. Okay, so these two things are like the basic building blocks of Hadoop architecture. Okay, so I will just draw the blocks and name them, and then we will start discussing those components basically. So what I will do is I will name them. So first thing is called name node. Second thing is called data node. Then we do have job tracker, and fourth thing is task tracker, and then we have one more component called secondary name node. Okay, so these are five, you can say, the basic components. Now if you talk about job tracker and task tracker, that is on the second row, the two components on the second row, second column basically. So I mean, these are like very older version when the Hadoop got when Hadoop got introduced basically. This job tracker and task tracker were there. Okay, now they are actually getting updated, or you can say the newer version of those components have come up, and that is what is something called yarn. In that yarn we do have resource manager and node manager, so we will discuss that later. But to talk about when the Hadoop got introduced, what was the overall architecture of Hadoop, these are like very five basic components. Okay, now if you out of these five components, let's we will name them quite a few times, like name node, data node, job tracker, task tracker, and secondary name node. Okay, to understand them at like very overview level is like what basically they are. Okay, so we can say that these are, you can we can say that these are Java programs. Okay, they are like independent codes. Okay, so codes in the sense like if you pick name node, so name node is a program. Let's say there might be some few thousand lines of code in that particular program of Java language, and the nature of these five components basically, you can say, whenever they start, I mean whenever you start name node or data node or any of this component, basically once you start them, they will never end or they will never stop. Okay, so they are like kind of ever running processes, or sometimes they are also called ever running daemons. Okay, so mostly they will either called processes or daemons. So mostly we will use daemons for daemon word for those processes. Okay, so if you talk like basically any in any application, basically there are certain jobs or there are certain processes, those need to run for longer time or for like all the times. Okay, so we do have a lot of processes on our Windows that keeps running at the background. Okay, and they will keep serving the things for which they are made. Okay, so these are also the similar kind of processes. Once they start, okay, they cannot stop on their own. Okay, so only 2 or 3 scenarios where they can be stopped is like some since they are like running processes, running programs, they might face some kind of runtime error, right? Like some array out of index or some file not found or some null pointer exception, all the Java related, Java world error they can face, and due to that error basically they might stop. Or if someone can go to them and then kill them. Okay, so only few possible ways through which they can be stopped. Otherwise, if everything goes fine, they will never stop. Okay, and they keep providing the services for which they are made. Okay, so now each of these daemons, they are being programmed, or they are being made in order to provide certain services. Okay, on in Hadoop basically. So when you talk about Hadoop, there are two very basic things that it will provide you. The first thing is called data management. Okay, so we know that in our earlier discussion that Hadoop is nothing but it's like kind of a distributed architecture, or distributed. It will be installed, or it will be set up in the distributed way. It means that there are multiple machines in a cluster, okay, which we call nodes, and each node will have their own capability, its own capability in terms of the CPU cores availability and the RAM and the hard disk. Okay, so we already know that. It means that we do have like plenty of hard disk available in our Hadoop cluster, depending on how many nodes we are having in that. Okay, so basically the first service that Hadoop will provide is the data management on large scale. Data management in terms of like you can store the data distributedly in the number of nodes in a particular cluster. Okay, and
Miman, this is I have one query. We have not talked in detail about cluster. The meaning of the cluster in terms of Hadoop. In the last class, we have never discussed about the what is a cluster, how it is, and all the stuff. It is not discussed.
So basically we had gone through one solution where what we call the scalability of and where we had increased the number of laptops in order to increase the capacity of storing the data in the fault tolerant way. That's what actually is cluster. You can, if you can group them, the whole number of laptops, basically it is said to be a cluster. Cluster is nothing but it is like kind of a group of machines together working for the similar cause. That's it. I mean, when you talk about cluster, that's it. I mean, it's like kind of a theoretical discussion only. We are not going to do any practicals today. So basically, we just need to clear our fundamentals regarding like when you talk about a cluster, it's nothing but it's a group of machine. Each machine is having their own its own like capability. So if you remember, basically we had drawn few blocks and we are actually marked them as a laptop. Okay, each laptop is having its own CPU cores plus RAM plus ROM, right? And then we added few number of laptops, and they say basically let's say 5 or 6 laptops or whatever, so you can say 5 or 6 nodes, and if you just like together they are said to be a cluster. That's it, nothing else. I mean when you talk about cluster, the dictionary meaning of cluster is nothing but it's like group of machine. Okay, that's it.
Okay, so how about node? Is it node relates to one particular machine?
Yes. So if I say 10 nodes, it means 10 laptops, it means one cluster. So in one cluster there will be 10 laptop or node. So it's like independent machine in a cluster is said to be a node. Okay, and one node is like having the server, or it's like kind of an individual machine on its own. I mean it is having its own operating system, its own resources, own networking. Everything is like it's like kind of completely hardware thing.
Okay, understood.
Okay, so we will actually go much deeper when we start talking about the Hadoop. So today we will dedicate ourselves to the Hadoop distributed file system, how it actually how it actually works, basically Hadoop distributed file system. Now this name node, data node, job trigger, task trigger, and secondary name node. So Hadoop provides two basic things. One is called data management part, and another is called data analytical part or data analytics part. Okay, when we talk about data management, so data management is anything that is related to copying the data into cluster, removing the data from the cluster. You can Just like so we know in every operating system, just like in Windows as well as on Linux, basically we do have some folders, some files. There is a way to create the folder, rename the folder, delete the folder, creating the, I mean, copying the data from external world, changing the existing data. You can remove the data. So that is what is called, I mean, on Windows operating system level or Linux operating system level, basically we can play with the files, folders, right? That is what is called mostly, I mean, that is what is actually holding the data. So similarly, when you talk about Hadoop, there is a file system associated with Hadoop, and that file system is called Hadoop distributed file system. Okay, and that Hadoop distributed file system is like basically designed for handling the data on the large scale. It means that like you can copy the data from some external world into the Hdfs or in any cluster of Hadoop. Then once you get the data into Hadoop cluster, basically, then again you can manage in terms of like where to put, okay, how many number of copies of that data needs to be like there. Okay, by default it is 3, where we have seen that the replication factor of HDFS is 3. It means that every block, or that the information will have 3 copies available, so that it would be fault tolerant in terms of like if any one copy will be missing, still you do have 2 more copies in order to serve your client requests. Okay, so these two things, that is what is called name node and data node, basically will provide you the facility of data management. Okay, and these two things, job tracker and task tracker, they will provide you the facility of data analytics on the top of HDFS data. So data management could be anything like getting the data, deleting the data, renaming the data, removing the data. If you try to manipulate the data, all those things you can do. Okay, and basically it is, when you talk about data management, it is mostly the directory level operations or folder level operations. Basically, when you, so let's say you are having some data in text file, right? So if you want to copy that into HDFS, okay, and this whole thing, name node and data management, name node and data node, it actually, we can call it HDFS, Hadoop distributed file system. Okay, and here the data analytical part is called MapReduce. Okay, this is Hadoop. I mean, basically when you talk about the overview level or architecture level, this is Hadoop. I mean, it provides 2 services. One is the data management services, and once you get the data into Hadoop, basically you can then further do some analytics on the top of it. Okay, the analytics is nothing but like kind of doing some programming on the top of data and then get some knowledge out of it. Okay, just like whatever we do in general applications, like no matter it is AS400 mainframe or Java or any other applications, basically what you do is you will interact with any of the database where the data is there, because whole application, no matter which application you will work with, basically it revolves around the data, and data is managed by some database. Okay, so you will have some records, some tables, some files, and some database. You will get it, do some kind of programming on the top of it, and then again either send it back to the database or send it somewhere else, like some kind of front end, right? So analytics is just like on the top of data. Now the data, since the HDFS is a scalable file system, it means that you can keep adding the number of nodes in order to increase the capability or capacity of your data handling in HDFS. It can grow up to like terabytes and petabytes of data. Okay, so we have seen that few examples where the companies, or there are some guys in the market like Facebook or LinkedIn or Twitter. Basically they are handling the data size much bigger than anyone else. Okay, they are handling the data in like terabytes, petabytes of scale. So we can in any data, depending on like which domain you are working, okay, maybe telecom or like in any other domain, basically data generation in that, depending on like whatever domain you are working, it can grow up to that level. Okay, and the HDFS is suitable in order to like store the data if you really want to archive it for longer duration, or even if like you want to do some analytics, real-time analytics on the top of that Hadoop data, you can use HDFS file system. Okay, since it is scalable, it can, you just need to add the number of machine and then you are good. Okay, now this name node and data node. So we will.
Sorry,
Mhm.
Vimal, sorry. Before you go to next thing, I have one question. When you say scalability, where you can scale it up to any limit with respect to the file system, or is there no limit?
Uh, that is good question. So the limit in terms of okay, so basically when you talk about the number of nodes, right? In terms of HDFS, basically it can grow till thousands. Okay, so it depends on, like, suppose if it is more towards the analytical part, like which actually decided how many number of nodes you can have in one cluster. Okay, so basically with the help with this job track and task, because ultimately you want to keep that much data only that you can do analysis. Okay, that you can analyze basically. So uh, I mean, if you talk about that limit, it is very large, and I'm not saying that there is no limit. There is a limit, but again, that limit is very large. Okay, so and what is the deciding factor for that limit is, let's say if you are working with job tracker and task tracker basically, and the architecture of this job tracker task tracker, uh, it is actually getting bottleneck over around 5,000 nodes. Okay, now how much data that 5,000 nodes can have still depends on, like, various factors. But like, say if I say 20 petabyte, 30 petabyte, even 50 petabyte is okay with Hadoop. I mean, you can go up to that limit. Okay, that petabyte of very large. But number of nodes, if you talk about the number of nodes in a cluster, you may have like 5,000. Limit of number of nodes is 5,000 for job tracker task tracker, and around 10,000 is for yarn. Okay, so you can go up to that many number of nodes. Now each node can have several terabytes of hard disk available. Okay, so there is a formula, just like you can just say that total number of space available divided by 3, and 25% also you need to just leave it for the other purposes, so that much data you can easily store. So let's say if you are saying 100 terabyte you want to store, then you need to have at least 400 terabyte data, sorry, 400 terabyte of hard disk should be available. Why? Because 100 into 6, because the replication factor is 3, so 300 terabyte you require definitely, and then 100 terabyte more for doing certain other operations, like operating system also needs some hard disk space in order to do certain kind of thing, and then some other processes also running at the same time. So that is like some rough calculation. For 100 terabyte you need to have 400 terabyte available. Now for 400 terabyte you can have that 400 terabyte on like, it is also possible to have that on a single or one or two node also. Only two nodes you can have 400 terabyte of hard disk. How come? So it depends on, like, so we do select it's like JBOD, just bunch of disk. The number of disks, the number of hard disk on one node is multiple. Okay, so you can have, let's say, 4 terabyte or 5 terabyte hard disk, and there could be 8 or 10 hard disks in per node. So you can have around 40 terabytes, 50 terabytes, till 100 terabytes you can have on one particular node. Okay, so again, it depends on complete architecture. But when you talk about limit, basically there are various factors that you need to look into. I'm not saying that there is no limit. There is a limit, but that limit is very high. Okay, that does not stop you for any, I think, any use case. Okay, you can have you can have that.
Okay, fine. I understood. So basically, we can have, there is a limit, but it depends upon the architecture, how we build it, and how
Yes.
much the data analytics, job tracker, task tracker can handle. That is fine. So with respect to HDFS data management, you said that a cluster can have 5,000 max of nodes, and in the previous version and the new version, what is that, yarn or
Yeah,
whatever,
yeah, correct.
it can have more than 5,000, up to
Yes,
10,000,
yes,
I
yes,
believe.
yes, yes.
Right. In that case, each node, so number of nodes in a cluster is decided by some factor, but at the same time, how does in a HDFS system, how many clusters can we have on each clusters? Do we have any restrictions?
See, cluster itself like kind of independent. You can have several clusters, but depending on like, uh, let's say you talk about any production scenario, right? They're kind when you talk when you actually work on real production systems of Hadoop, basically you may have like variety of clusters basically in terms of the number of nodes, right? Sometimes you may see not more than 50 nodes, or sometimes 40 nodes, 100 nodes. Now there are some larger clusters that come up like 500 nodes, 1000 nodes. Till that there is a limit basically. Only Facebook and then very mammoth the companies who are handling like very large sites of data, they will have some few thousands of machines in their cluster. But when you talk about the general production system of Hadoop, you may not see no more than few hundreds of nodes. Okay, and that is too less. Okay, if you talk about 5000 nodes, 500 is nothing in front of it. So basically
So they manually, sorry to interrupt.
no, no.
So basically, they might have few hundreds of nodes, but
Yeah.
that will be managed in one cluster.
Yes, yes,
And
yes.
is there any chances that we will have multiple clusters
Yes, we
to
do have.
manage also?
We do have. We do have.
Okay.
Okay, so the it's like kind of a development cluster, then a SIT cluster, then we do have a real production cluster, just like kind of when you talk about any general application development, basically we do have some development environment, then dev or SIT environment, and then so these are like clusters only. Though the number of nodes in those clusters are like, suppose if you are running 100 nodes of production cluster, you need not to run the same number of 100 nodes in your development cluster. You can have 10 nodes or 15 nodes, and then similarly, what do you have for development? You can have similar cluster setup for your dev and SIT. And then whatever you do on the development, basically with some smaller data set, you just need to promote it onto dev and SIT, and then finally you can promote your overall solution to production, where the actual size of data on actual size of data it will run. So that's the way you will have multiple clusters in that way. In production also you can have multiple clusters depending on your overall application, your overall use cases. Yes, but it is possible, and you can do the cluster to cluster data copying to particular cluster, or more than one Hadoop cluster can work in tandem to with each other in order to do some different workloads. Does it answer your question?
Okay. Yes, that is my question. In production, do we have multiple clusters, and which scenarios do they use these different things? I believe this is a very rare scenario, or is it the real time production scenario that we have multiple clusters? I'm not talking about the environments like
Yeah, I know.
development environment, SIT production, but
Mhm.
in general, in production environment, do we maintain more than one cluster to do some
Yeah, I mean,
analysis or
yes,
yeah.
yeah. So see, basically, not generally. I mean, most of the projects they do have only single cluster in the production, where because uh, the nature of the work, the overall the use case, the overall analytics that they want to perform or keep the data in the production, basically, mostly generally, it would be 80% it would be like a kind of single cluster in production. But there are some cases where definitely they might have more than one clusters, depending on different use case. So let me tell you one example. Basically, let's suppose if you just need to maintain the data and do some analytics, okay, that is where you will build one cluster. Then suppose if you want to really do some kind of streaming analysis, like let's say some you are collecting the data from multiple servers in the real time using Kafka. So they you can build a Kafka cluster just like in Hortonworks HDF, that is what's called Hortonworks data flow, where you will have the Kafka and only the component that is related to do some kind of real-time analytics. So you can have separate cluster for doing some fast real-time analytics. Okay, so in those cases, basically you will definitely have multiple cluster in your production. Okay, but then again, it depends on what workload you are trying to perform on that, and basically what kind of nature you are having. So mostly, just to do some kind of batch analysis, you collect the data and then do some kind of analytics that runs over the night and then give the results in the next morning, and you will just look into the report that okay, what happened yesterday. That is one case, one workload kind of thing where you do have one cluster. Then if you do have real time data analytics or real time feed that comes in and you really want, and that real time feed is also like in huge amount in some few 100 GBs per minute kind of workload you do have, you can build a separate cluster of all that. So again, it depends on nature and workload. Though these two things can be also done on the same cluster, there is no need to do some separate cluster. But depending on the data size, depending on the nature, depending on your user who are actually using that cluster, you can easily segregate your workloads into different clusters of Hadoop, even in production.
Okay. Okay.
So data management. So here, what we can do is we can do copy, we can do and basically Hadoop does not generate the data on its own. Basically, just like, since it is just like kind of storage, you can just consider it to be hard disk, right? If you really want to do some, if you really want to have the data, you need to get it in from outer world. Okay, so there are like you are doing some lot of banking transactions or insurance transactions or any other application like telecom domain or supply chain domain or pharmaceutical domain or petrochemical domain. There are some data is stored already in your data warehouses that you can move into data in Hdfs, right? So we had seen that what was prior to Hdfs or this kind of big data problems, there were some data warehousing solution providers, companies like Greenplum, SAP HANA, IBM, Netezza. Okay, those are systems in which the data might be there in order to have your data warehouse. Okay, so they might have like years of data to be stored in that. So you can just get that data into Hdfs to provide you more visible solutions in terms of kind of like mass storage and archival of it. So it does not generate Hdfs does not generate data on its own. You need to get it from outer world. Okay, that is one more fact. Then we do have job tracker, task tracker. That is a data analytical part. Yeah?
Sorry. Mm-hmm. Sorry. I have one more question came in my mind.
Mm-hmm.
You said the data archival process.
Mm-hmm.
So for the data archival process, do we need to still need the HDFS file system, or we can manage it outside the HDFS file system?
See, the thing is, when you talk about the terabytes of data, plenty of data, so you cannot that you cannot store on a single machine. Basically, HDFS can give you some very good option in order to store the data, even though you can consider it to be archive. Means you may not use it for analytics, but still you require that data because you never know that whenever you are going to need it. Okay, so that's why, like, let's say if you're doing a business, let's say you have run your whole business for 5 years, 6 years, and you have generated a lot of data in terms of like sales and purchases and a lot of other transactions and other kind of data you do have. And then you are trying to find a solution which will because ultimately no business basically want to delete any of its years data. Let's say if it is doing the business for 5 years, so they are not going to delete the whole data for first year or second year, right? They need to keep it. They want to find some solutions where it can be archived for longer duration, so that whenever it is needed, we can just go there and retrieve whatever we want. Okay, so HDFS is very, very best solution for that, in order to, because the thing is, let's say you go by year in your business, and you can just keep adding number of nodes in your HDFS cluster basically, and just you can increase the data handling capability or data storage capability in HDFS. So that's what actually called archival. That is the solution that HDFS provide, just to archive the large amount of data.
Yeah. Sorry to interrupt. Yeah. Yes, I understand that. But my question is for archival purpose, do we use HDFS file system? Is what my question. So do we maintain it separately outside the HDFS? I'm just talking in terms of real live environment. So if you see any bank related websites, only for certain period of time, only for a 6 months period, you will be able to retrieve the statement online. Yeah. But anything goes behind that, then they may need to request, and it will come from a different time. It is not real time.
Yes.
So in that case, the real time information might be from the HDFS file system, because you will be querying the data on a real time. But when it goes to it will be used in the same HDFS system, or it will be a completely different out of HDFS?
So I got your question. So in that case, you can, because the thing is, even if want your statement 6 months back, let's say before 6 months, and prior to that also like 6 months more, basically you want, if you, so it is not the real time. I mean, you need to submit the request and then somehow they get it pulled from archival and then send it on over your email. So basically no, it does not suitable for that kind of real time systems. Okay, when you have the data in HDFS, though we do have like HBase as a database available that can query the data in the real time, it is somewhat faster than but it is not actually real real RDBMS. Okay, the response from this HDFS would be very, very slower. Okay, you cannot treat it for like kind of what we called OLTP, like online transaction processing. Okay, it's mostly suitable for OLAP processing, online analytical processing. So for answering your question, basically no. I mean, even though you have the archive, you have a lot of data in HDFS that is archived in that, but if you really want to query it and then get some result, it requires some time. It cannot be treated as a real time.
Okay, fine.
Fine. So we do have name node, data node, job tracker, task tracker, and secondary node. So this is Hadoop. I mean, we just need to keep, since like we learn it for the first time, basically we keep name it. Okay, and then now we need to understand. So we have got like few points about like what are these things: name node, data node, job tracker, task tracker, secondary name. These are daemons, ever running daemons. Once they start, they will not stop. They will keep providing the services for which for what they are made, basically, and they will stop only when some internal error happen and someone from external world can go and kill them. Okay, then only they will be stopped. Okay, so let me stop the recording here.